Hi, Professor. This is Alexis Wisnat. I am doing a presentation on the prototype pattern, cloning autonomous robots. Just for background, I am really big into the autonomous robot area right now. It's quite entertaining, especially with NVIDIA's new things that they've come out with relating to autonomous robots, and their partnership with 1X and even Disney. So this is an area that I really enjoy, and I thought it would be nice to see how it connects to the prototype pattern. So I'll put into slideshow. And just an introduction, I'm sure you have background on autonomous robots, but they are robots that are usually ran by AI, and they live independently. So they're able to make their own decisions based on, learning through AI. And a lot of them that I've seen recently, they can work in manufacturing spaces, they can live in homes and do home chores for you. So that's a little bit of the background of that side, and specifically what I'm discussing here when it comes to the prototype patterns is the cloning of these autonomous robots or duplication, whatever you want to call it. So yeah, that's what the basis of this is being able to use the prototype pattern to clone those robots in future. So the intent here, what are we looking to solve? So as you'd expect, when cloning robots, even just making robots in general, right? The basis of it, making a autonomous robot is ridiculously time consuming. I mean, just like building it out in itself, the back end and the front end, then actually connecting it to the robot. I mean, I can't even imagine. Um, so that in itself is extremely time consuming. And then you think about having to build more than one, right? That would take an immense amount of work and effort. And it just doesn't have the longevity that's needed for if you were to have a business around this. If you're just creating your own, one might be fine, but long term, you need a more viable solution for that. So, along with this, it's just inefficient. And then also, if you are doing this manually, so um, on your own, just step by step, then there could have human error with it. So, even if you have a whole team, there's more likeliness of human error than if you were to have it within this prototype pattern and be able to do it automatically, which would be really nice. So that is the solution using the prototype pattern to be able to clone those autonomous robots and their code and all the back end parts of it for that quick replication of those. And especially when it comes to those specific tasks, because sometimes robots could be built for very specific things. Especially maybe if it's in like manufacturing, you just want it to be able to bring one part from the left side to the right side. So you'd want to be able to clone that specific portion of the robot, and then in other ways, maybe bring it to left to right side. And yeah, the prototype part, like I said, it just leads to less error, human error, because no matter what, when humans are involved, there will be some form of error, especially when there's a lot of steps and if there's multiple people involved. So here is my class diagram. What you can see here is, I mean, it's pretty basic and straightforward, right? There's the class robot, which the purpose of this is to be able to define that base structure. And it's allowing that like cloning behavior for all of the robot types. So whether it's a robot that again could bring one machine part from the left side to the right side, or a machine part from the right side to the left side, it's able to pull in any type of behavior regardless of what it looks like. So that's what the premise of the class robot is. There is class navigation robot right here, and this pulls in the different specialized tasks, navigation tasks. So this might be something like direction or where it wants to go, things like that. Where the robot's like purposed out for navigating. And then we have the class delivery robot, and this is just straightforward delivering the payloads. And then class inspection robot. This is for robots that are tailored for inspection and analysis. So think of it as, again, kind of going back to that manufacturing example. If you have a robot in like a car plant, okay, and it needs to be able to inspect a specific car or test it out and make sure that it does what it needs to do, and it's hitting those safety numbers, and it's able to protect if a human is navigating it and within it. So that inspection robot is able to make sure that all those protocols are in place for inspecting or analyzing. So now we go to the demo and output. So I'm going to quickly just move over here. I mean, it's pretty much the same thing that's on this slide, but I just wanted to have it available for you. So we have VS Code right here. And yeah, so these are all the pieces to the puzzle. I did add this section here as like an example usage portion, which I think could be really helpful for you. So this is where that printing part comes out as, and this was just an example that I had. So say, for instance, you wanted to use 100 of the delivery bots and just one inspect bot, then that's what it would look like. And then there's specifically the NavBot prototype. So this is what it would look like in that sense for the back end portion of it. So we'll go back in here. There's a slideshow. So the advantages to this, I think it's pretty clear at this point that a lot of it is just efficiency. As we're moving towards a more and more efficient world, we need to have better processes in place, and having this prototype pattern that allows maybe a team to be able to clone these robots in an efficient way is going to not only save a lot of time, but is going to be a really important resource when it comes to how fast technology is moving. Because if you have one company that's using manual processes versus a company that might be using this prototype pattern to clone things, the company that's cloning things, they're more likely to get products out and customers and money, right? Because if they're getting the product out on the shelf and it works well, then people are more likely to buy that than one that is, time after time taking a while to be able to produce. So ultimately, just the efficiency altogether of having the copy of that pre-configured instance is really important because you don't want to have to keep building it from scratch over and over and over. Then we have reduced redundancy. So, in the grand scheme of things, having that redundant code for robot initialization, that can create a lot of background data, and it will cause the computer to have a lot more high computation, which ultimately takes a lot more energy, and you just want it to be able to use from one specific source and be reused in that sense. So it's not, you don't want it to constantly have to keep reusing it in a redundant sense. You want to keep it efficient. And then there's the flexibility and dynamic configuration. So this is also really big because it allows you to change those prototypes at runtime. And, once again, kind of going back to that efficiency model, just being able to keep it quick, clean, and then customizable after that creation. If you're able to have at least like the backbones of it, you can adjust it as time goes on if there's specific items that need to be added. So if it needs to walk, you can keep cloning that and then add on to whatever else. So if it's like, okay, well, it needs to walk to the door and open it. If it needs to walk to the kitchen and grab you a drink or whatever it may be, it has that standard set already in place, which is really important. And then the simplified object creation. Of course, like when you're developing and creating a robot that is extremely complex, and it has complex objects, it can take a lot of effort and be extremely cumbersome, as it states right there. But Being able to utilize this prototype pattern, it allows it allows you to be able to be a little bit more complex and not have it be so cumbersome because you're able to use those clone methods over and over and over. And it's again just kind of going back to the efficiency part. It makes it a lot more efficient in that sense. So you're not having to do the same thing over and over and over. All right, and the disadvantages to using the prototype pattern. So we have deep copying complexity. When it comes to this, it's it can be a little bit challenging just for the sole fact of having nested components. I think in general, just having nested components can be challenging on its own. But then when you're mixing it with the complexity of autonomous robots and them being physical and in person, and you never know what could go wrong when it comes to those nested components and the different types of steps that the autonomous robot has to take, it can be challenging. And you just want to make sure that you are very careful with the clone methods that you're utilizing within the code and you're utilizing them in the correct way. And then also the circular references within the robot configuration could cause issues as well. So whenever you're building this out initially, it's really important to make sure that you're double checking the code and that these clone methods are used in the correct way and the appropriate way. So then there's not any issues with the complexity of the robot in itself. And then there is the prototype management. So within the robot registry itself, if you have a large number of prototypes, when it comes to the cloning side of things, it can be extremely large and complex. And if you have to manage it yourself, that's a lot of overload of work. It could potentially at some point be managed autonomously in some sense, right? That's something that you could implement into your process, but initially it probably would be a lot to make sure that it is organized within storing in the cloud and being able to retrieve those prototypes that you have. Then we have the potential performance overhead. So like I was saying earlier, that computation power that's required to not only run maybe one autonomous robot, but multiple autonomous robots. And not only just that in itself, but if they're extremely complex, if they're doing a lot of different tasks, if they're able to go get you a coffee, close the door, fold your laundry, whatever it may be, that can take a lot of power. And that's a lot of data and a lot of testing. So there's a lot of performance overhead issues and concerns that might take place in that sense, but just continuously testing and trying to improve it after time could potentially help. Then we have maintenance of clone methods. So going back to the management, depending on how complex these are, it could be, a lot to manage and make sure that the performance is as expected. So it's really important that each class that you're implementing within the robot class, they must also have that clone method that's involved with it. And then we have some real world applications. So, let's say for instance, you have a company that you're starting and you want to mass produce those autonomous robots. Um, it's just like with anything, any company that you have, you want to be able to produce as much as you can so then you can make as much money as possible. So being able to mass produce these robots is really important. The GUIs for the cloning UI elements, document editors, games, being able to clone game characters, I think is that's like pretty standard. Configuration for setting up profiles, and then maybe even like finance. I was thinking that could be relevant in some form for those financial models. And that is all. Thank you so much for your time and listening to this. And I hope that it was beneficial for you and maybe a little bit entertaining when it comes to the autonomous robot side. But thank you.